Then you have a subsection through a portion of the medulla and the cortex. So this is the medulla, this is the cortex. And then you have a really close-up view just on a glomerulus. Right? So if we start over here, let's first start by talking about the renal pelvis system, which drains the urine from the kidney. So you've got the ureter, which connects up to what?
Bladder.
The bladder. So 2 ureters, 1 from each kidney. The ureter is actually an extension of the renal pelvis. The renal pelvis is like this funnel that sits in this open cavity space. So if I were to pull the renal pelvis out, pull that funnel shape out, the space that's left behind is the renal sinus. So the renal sinus is basically the space that the pelvis fits into. The pelvis branches out, and it's got large branches which are called major calyces. And each major calyx then branches further into a minor calyx. So the minor calyces are the ones that abut the collecting ducts. So the collecting ducts come down, right? And the point at which they intersect with the minor calyx is called the papilla. And that's in your book. I don't know if it's on your list or not. Mm-hmm. So basically we're making the urine out here in these tubules, right? And as the urine is being made, it's all draining into the collecting duct, through the papilla to the minor calyx, then through the major calyx, into the pelvis, and out the ureter. So this whole structure is meant to drain urine from the kidney. Okay? How are we making the urine? We're making the urine through the filtration of the blood. So we also have to talk about the blood supply coming in. Extremely important. So you have the renal artery. The renal artery then splits into interlobar arteries. And the way that you can look at this is we know that the outer portion of the kidney is the cortex. The inner portion shown here is the medulla. Parts of the cortex actually extend down between those medullary pyramids, right? Renal pyramids, renal columns. So the renal pyramids are made up of the medulla. The renal columns are the cortex that's extending down in between. So these interlobar arteries extend up through each renal column. Good? Mm-hmm. All right, so they basically, think of interlobar as dividing the kidney into sections. So like sections of an orange, or sections of a grapefruit. Lobulars up here. Okay. Yep. So then, if we look at these top arteries that connect those interlobar arteries together, their shape determines their name. Arcuate, as an arc shaped. And then each arcuate artery is divided into the interlobular arteries. Okay? The whole idea of this blood flow coming in is to bring the blood up to the level of the glomeruli. So you can see here, repeated, interlobar artery, arcuate artery, interlobular arteries. And then the afferent arterioles are the tiny blood vessels that feed the glomerulus itself. And the glomerulus is just that bundle of capillaries. So if we look at this, this is a large-scale view of the glomerulus. So the blood is coming in. The fluid portion of the blood, a portion of that, is being filtered, meaning it's leaving the bloodstream and it's entering this capsule and then entering the proximal convoluted tubule, entering the first part of this kidney tubule. Good?
So the renal corpuscle?
The rest of the blood all just stays within the vascular system. It just comes out the efferent arteriole, and that's just going to join up to the capillary beds and drain the blood back out. How does it drain? Interlobular vein, arcuate vein, interlobar vein, renal vein. Same names coming out the other side. Okay? So the part of the blood that was left behind, that was filtered, we now call filtrate. And it's similar to plasma in terms of its constituents, but it doesn't have the large plasma proteins because those were too big. to be filtered. But it does have things in it like sodium, chloride, calcium, glucose. Most of that stuff we want to keep. So in this proximal convoluted tubule, we reabsorb it to keep it. It's reabsorbed back into the bloodstream through these capillary beds. Okay? Anything that's left in the tube continues down the tube. Some along the way, again, is reabsorbed. Mostly salt and water is reabsorbed in this loop. By the time we get to the end of the tubule and we have that filtrate collected into the collecting duct, now it's urine. Right? By the time it gets to the collecting duct, it's going to leave the body. That's going to be excreted. So if we look at the tube, the first portion of the tubule is the proximal convoluted tubule. Proximal means near, convoluted means curved. So it's nearest the glomerulus and it curves all over itself. Okay, proximal convoluted tubule. Then we've got this hairpin loop called the nephron loop or loop of Henle. It's got a descending limb that comes down and an ascending limb that comes back up. The main function of this nephron loop is to allow for salt and water reabsorption, which allows us to maintain those important electrolytes and maintain the fluid, and helps us to also then, by the time we get up to the distal convoluted tubule, to concentrate the urine. Okay. This is also why you guys were asking about urine color. A more concentrated urine is going to have a darker color because it has less water content. Someone who's very well hydrated has a lot of water content in their urine, and therefore it's a really light color. It's less concentrated. The juxtaglomerular apparatus is another one that was on your list. It is essentially sandwiched between, and there's a good picture of it here too. What is this? 801 in the old book. So you can see the capillaries. Here you can see where the afferent and efferent arteriole sandwich up against the distal convoluted tubule. That's what this guy is right here. It's part of the distal convoluted tubule as it winds around. So the juxtaglomerular apparatus is composed of specialized cells that help us to regulate our fluid and electrolyte balance as well as our blood pressure. So the kidney flow is directly related to your blood pressure. If your blood pressure goes down, your kidney flow goes down. If your blood pressure goes up, your kidney flow goes up. Okay? That can be sensed through this apparatus. And let's say your blood pressure goes down for some reason, it'll cause the kidney to release renin. And renin acts as a hormone within the bloodstream that takes another substance found in your blood called angiotensinogen and converts it to angiotensin 1. Angiotensin 1 is then floating in your blood, and as it travels through your systemic circulation and then back through the pulmonary circulation to the lungs, it's converted to angiotensin 2. Why does it happen in the lungs? The enzyme that causes the conversion is found in your lungs. Okay, angiotensin converting enzyme, or ACE.